Let's take a look at these examples. Again, we are going to perform the subtraction of the binary numbers. First example, we have 1, 0, 0, 0 minus 1, 1. Of course, we talk in terms of the binary numbers, base 2. I cannot subtract 1 from 0. That's why I'm going to borrow 1 from here. Borrow 1 from this one becomes 2 over the next bit. But I have to go up to this point, up to this bit. So what I'm supposed to do, I'm going to borrow 1 from this 2, and I'm going to have 1 over here, and the borrow 1 is going to be 2 over the next bit. Again, I'm going to borrow 1 from here. This is going to be 1, and it's going to be 2 over the least significant bit. So I have 2 minus 1. 2 minus 1 is equal 1. 1 minus 1 is equal 0. 1 minus invisible 0 is going to be equal 1. And this is, of course, is going to be 0. I don't have to write it. And let's take a look what we have got. This is 1, 0, 0, 0. This is 1, 0, 0, 0. This is binary 8 minus 1, 1. 1, 1, 2 plus 1 is equal 3. Minus 3. So this is 8 minus 3 is equal 1, 0, 1. 1, 0, 1. This is going to be binary 5. 8 minus 3 is equal 5. So this is the solution to my first problem. Let's take a look at the next example. We have 1, 1, 0, 1 minus 1, 0, 1, 1. 1 minus 1 is equal 0. Of course, this is base 2. I cannot subtract 1 from 0. That's why I'm going to borrow 1 from here. This 1 over the next bit is going to be 2. 2 minus 1 is equal 1. This is going to be 0 because I borrow 1 from here. 0 minus 0 gives me 0. 1 minus 1 gives me 0. So let's take a look what we have. This is nothing else, just binary 13, 1, 1, 0, 1, 1, 1, 0, 1. So this is 8 plus 4 gives me 12 plus 1 is 13. So this is binary 13 minus 1, 0, 1, 1. 1, 0, 1, 1. 8 plus 2 is 10 plus 1 is 11. Is equal 13 minus 11 is equal 2. 0, 0, 1, 0. 0, 0, 1, 0. We have 2 over 1. So this is binary 2. So 13 minus 11 is equal to 2. That's why this is the solution to my problem. Let's take a look at this example. We have 1, 1, 0, 0, 1, 0, 1 minus. Anytime you are going to rewrite the problem, you're supposed to make sure that you are going to start writing from the least significant bit. Means you have to start from the back and copy this down. 1, 1, 0, 1, 1. Of course, this is base 2. And perform the subtraction. We have 1 minus 1 is equal 0. I cannot subtract 1 from 0. That's why I'm going to borrow 1 from here, and this 1 becomes 2 over the next bit. Remember, borrow 1 over the next bit is going to have value of your base. So that's why I wrote 2. 2 minus 1 gives me 1. This is going to be 0. 0 minus 0 is equal 0. And next, please notice that we cannot subtract 1 from this 0. That's why I'm going to borrow 1 from here. This 1 becomes 2 over the next bit, but I have to subtract from this 0. So what I'm going to do, I'm going to borrow 1 from here. This becomes 1, and I'm going to have 2 over the next bit. 2 minus 1 gives me 1. 1 minus 1 is going to give me 0. 0 minus invisible 0 is equal 0, and 1 minus invisible 0 is going to give me 1. So this is the solution to my problem.